Hello friends, welcome to my e-clinic. So today we'll study about enamel. Before this we had studied development of tooth in detail. In this video we would be studying about general features of enamel, and in the upcoming videos we'll study about the life cycle of ameloblast and amelogenesis in detail. So without any further delay, let's begin. Enamel is a miracle tissue. How miraculous it is. Let us see in detail. Now, the enamel, it is the hardest structure present in the human body. It is the hardest structure and it covers the crown surface of the tooth, forming a resistant and protective covering. Now, the maximum thickness of enamel, it varies in various regions of the tooth. It is highest in the cusp region, which is 2 to 2.5 millimeter, while it is lowest in the cervical region, which is 0.3 to 0.5 millimeter. So now the thickness of the enamel, it varies in various areas of the tooth, and also if we take into consideration the upper molar and the lower molar. So if this is the upper molar and this is the lower molar, this is the palatal cusp of upper molar and this is the buccal cusp of lower molar. We can see enamel is very thick than other parts of the crown in the palatal cusp of upper molar and buccal cusp of the lower molar. Why so? This is an adaptation to functional demands. What is the chief function of the tooth? The chief function of the tooth is mastication. So when we masticate or chew the food, it is principally chewed between the palatal cusp of upper molar and the buccal cusp of the lower molar. So in these cusps, the enamel thickness is higher than the other region. Other property, the specific gravity of enamel is 2.8. Now this question is asked in MCQ, so please remember the specific gravity of enamel is 2.8. Now let's comment about the hardness of enamel. If this is the tooth covering with enamel, the hardness of the tooth, it is maximum in the cusp region and minimum in the cervical region. Also, as we approach from the surface to the core, the hardness of the enamel reduces. Then permeability of the enamel, it acts as a semi-permeable structure. It allows certain ions and molecules to pass through it. Now let's see why some people have a perfectly white color of teeth while others have yellow. This color of enamel is determined by the calcification of the mineralized tissue present in the enamel. This mineralized tissue, it regulates the translucency of enamel and thus the color varies. Let's study this in detail. If a tooth has less level of calcification, then the enamel of that tooth is less translucent, as a result of which when light strikes the enamel, it reflects the color of the underlying yellow dentine. So the tooth appears yellow. On the contrary, if the calcification level is high, then the translucency is also high, and the yellow color of the dentine is not seen when the light strikes. So the teeth appears white. If we notice, some people have white teeth, but at the incisal or at the cervical area, there is yellowish tint. So what is the reason for this yellowish tint? In this area of the tooth, the enamel is thin, as a result of which when light strikes this area of the tooth, it reflects the color of the yellow dentine in the cervical area. And in some people, the teeth are white, but the incisal edges have a bluish tint. In these cases, the incisal edge is made up of only two layers of enamel and no dentine, as a result of which there is a bluish tint to the incisal edge. Now let's study about the chemical properties of enamel. So what makes the enamel the hardest structure of the body? This organic content, which is 96% and only 4% of the organic structure and water. Now what is this organic structure 4%? The organic material present in the enamel, it comprises of proteins which are exclusive to the enamel. These proteins are of two types, the amelogenins and the non-amelogenins. The amelogenins contribute 90% of the enamel proteins, while non-amelogenins comprises 10%. Amelogenins 90% and non-amelogenins 10%. The amelogenins are low molecular weight proteins while the non-amelogenins are high molecular weight proteins. Amelogenins are rich in protein, histidine, glutamine, and leucine, while non-amelogenins are rich in glycine, aspartic acid, and serine. Some of the examples of non-amelogenins are enamelin, tuftilin, and ameloblastin. All these questions are asked in Viva, so students, please remember all this. Now let's study about the inorganic structure of enamel, which is 96%. So this 96% inorganic structure is in the form of hydroxyapatite crystals. These hydroxyapatite crystals, when viewed under cross section, they are hexagonal in shape. These hydroxyapatite crystals together form the enamel rods. Now in hydroxyapatite crystals, we see the composition of these. The central portion of these crystals are rich in magnesium and carbonate. This richness of magnesium and carbonate makes these central part more acid soluble. That is, if this hydroxyapatite crystal is treated with acid, this inner protein gets dissolved soon. Also, we can see there are few water droplets or water molecules present in the hydroxyapatite crystals and around it. Now the enamel rods. Enamel is made up of enamel rods or enamel prisms. The number of these rods vary in differently. In the lower lateral incisor, 5 million enamel rods are present, while in bigger tooth such as upper first molar, around 12 million of enamel rods are present. Let's comment on what is the length and diameter of these enamel rods. The course of these enamel rods is not straight. It is tortuous, wavy, but not straight. Okay. This tortuousness of the enamel may be longer than the thickness of the enamel. Okay. So the tortuousness, the length of the enamel rod is more than the thickness of the enamel. And we can also see that the enamel rod which is present in the cuspal area are longer than those present in the cervical area. Now how about the diameter of the enamel rod? The diameter of enamel rod is also not the same throughout. It is less at the dentinal area of the DEJ and it is more at the surface. So this diameter increases from the DEJ to the surface in the ratio of 1:2. So for example, if the diameter of enamel rod is 1 micron at the DEJ, it doubles at the surface, that is it becomes 2. On an average, the diameter is 4 micrometer. Now let's study the cross section of these enamel rods. Mostly they are hexagon as we have seen. But in some cases, they may appear round, they may appear oval, they may appear arc-shaped, they may appear as fish scale, sometimes they may also appear as keyhole shape. Let's study the ultrastructure of enamel. That is, when the enamel is viewed under electron microscopy, how does it look? The enamel rod's shape can be well appreciated as keyhole shape when viewed under electron microscopy. Okay, as keyhole shape. Then if any enamel rod is cut in a longitudinal section along the length and viewed under electron microscopy, the sections pass through the head of one row of the rod and the tails of the another rod, which gives rise to the keyhole appearance. This part of the keyhole is called as the body. This is called as body. And this part is called as the tail. Now let us study about the striation of enamel rods. If the enamel rods are cut longitudinally, if enamel rods are cut along its length and viewed under ground section, we can appreciate that there are striations which are present on the enamel rod. There are striations which are present on these enamel rods. These are at average distance of 4 microns from each other. What is the relevance of these striations present on the enamel rods? They represent the rhythmic pattern of enamel formation, and there is also some diurnal variation in enamel deposition. The rate is different in the daytime and the rate is different at the night time. This is called as the diurnal variation. And these striations are more visible when the section is treated with acid. Now, what are the direction of the rods? The direction of enamel rods is different in deciduous teeth and permanent tooth. In the occlusal two-third, the direction is same. That is, it arises from the DEJ, runs a very course and ends on the enamel surface. In the cuspal area, they are almost vertical, and towards the middle of the crown, they become horizontal. But in the cervical direction or cervical area, the direction of the rods is different. In deciduous teeth, they retain their horizontal course, while in the permanent teeth, they turn in an apical direction towards the root apex. These rods have wavy course, and we can describe this in a small example. If in the middle part of the crown is divided into thin horizontal disc, as shown here, if it is divided into thin horizontal disc, the rods in adjacent disc, they turn in opposite direction. For example, rod in one disc start from the DEJ, run in oblique course and turns toward the right, while in the adjacent disc, it turns towards the left. Now let us study one more important terminology, that is the gnarled enamel. This question is frequently asked in Viva, so don't get confused with it. Remember, gnarled enamel is an optical appearance. First answer you should give, it is an optical appearance. If the enamel is cut in oblique plane at the cuspal region near the dentine, if this section is viewed, the rods in these section seems to be more intermingled between each other, giving it an irregular appearance. This irregular looking enamel is called as the gnarled enamel, and it is an optical appearance. What is Hunter-Steger bands or the HS bands? Now we have seen that there is change in the direction of rods. This change in direction of rods is responsible for the appearance of these Hunter-Steger bands. It is best seen when the tooth is cut in its longitudinal section. So if the tooth is cut in its longitudinal section, the ground section is made and viewed under oblique reflected light. So what we see is that there are these alternating dark and light bands. Okay, so there are alternating dark and light bands which originate at the DEJ, pass outward and end some distance from the outer enamel. These alternate dark and light bands are called as Hunter-Steger bands. Now what causes these dark and light bands? The dark bands appear when the enamel rods are cut in longitudinal section, and light bands appear when the enamel rods are cut in transverse section. These dark bands are called as the parazones, while the light bands are called as the diazones. These are the alternating dark and light bands of the Hunter-Steger. There is an angle between these parazones and diazones which is 40 degree. This is also an important multiple choice question. Now, why these HS bands appear? There are three schools of thoughts. Some scientists feel that there is variation in calcification of the enamel which causes these Hunter's trigger bands. Second, few scientists think that there is a difference in permeability and composition of the enamel matrix, which causes these HS bands. But the third and the most widely accepted theory is that there is change in the direction of the rods, which causes these Hunter's trigger bands. Now, the incremental lines of Regis, last topic for today, or the striae of Regis. What are incremental lines of Regis? These are the lines which represent the incremental pattern of enamel growth. The enamel is laid down in layers, and these incremental lines, they represent the incremental pattern of the enamel growth. These lines may be hypomineralized or they may be hypermineralized. So how do they appear under microscope? When viewed under longitudinal section, they appear as brown bands which appear near the cusp of dentine. In the cervical area, they run obliquely and deviate occlusally. They arise at the DEJ and deviate occlusally. In transverse section, we can see them as concentric circle. Now, what is the daily rate of enamel formation? It is 3.5 micron. It increases from inner to outer enamel. This rate increases as from inner to outer enamel. The evenly spaced striae of Regis show a 6 to 11 day rhythm. Moderate amount of incremental line of Regis are considered as normal, but stress and metabolic disturbances may cause a disturbance in these striae of Regis, making them more broadened. So in this lecture, we have studied about various structures of enamel, and the next lecture we'll be studying about enamel cuticle, lamella, tufts in detail, and also various age changes in enamel. So friends, if you have liked the video and found it helpful, please like, share and subscribe to my channel.